This question is about degree, minutes, and seconds. You have to know that 1 degree is equal to 60 minutes, and 1 minute is same as 60 seconds. Another way to say it would be 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute. Now, combining these two, you can also say that 1 second is 1 over 3,600 degrees. Okay. Now, the question is asking you to add 2 degree, minutes, and seconds. Let me try to do this just horizontally, but then I'll show you a new method which you can add vertically, and that's probably the one that you would want to use. But doing this way will enable you to see what's going on. Okay, so 10 plus 12 degrees, then 36 minutes and 42 minutes, and then you have 30 seconds and 56 seconds. Okay, so you have these two angles. When you add them up, you can just add the degrees together, minutes together, and seconds together. Degrees would add up to 22. The minutes, this will be 78. And 5 plus 3 will be 8, so 86 seconds. But then we're going to use this fact that 60 minutes is 1 degree. So you can rewrite this as 60 minutes plus 18 minutes. Same thing here. You can rewrite it as 60 seconds plus 26 seconds. And because we know that 60 minutes is 1 degree and 60 seconds is 1 minute, you now have this as 23 degrees, 19 minutes, and 26 seconds. So your final answer will be 23 degrees, 19 minutes, 26 seconds. Okay. Now, for the quicker method, I did this first way just to show you how things work. Now you can see it done much faster when you add them vertically. So let's add them vertically. So 0 plus 6 is 6. 3 plus 5 is 80, but 80 is more than 60, right? So you put a 2 here, and 60 seconds will be 1 minute. So I put a carryover here. 1 plus 6 plus 2 will be 9. 3 plus 4, that's above 6 again. So 7 is 6 plus 1, so leave the 1, and the 6 will become 1 degree. So when you add them, you're going to get 3 and 23. So you get the same answer this way, and this is the faster way. Convert 10.572 into degrees, minutes, and seconds. Calculator answers will not be accepted, and you must show your work. Okay. All right. So what do we mean by this? Well, 10.572 degrees is 10 degrees plus 0.572 degrees. And remember, 1 minute is 1/60th of a degree, and 1 second is 1/60th of a minute, which is like 1 over 3,600 degree. Okay. So using this, you can ask the following question. What is 0.572 in terms of something over 60 plus some decimal? So I'll just put D here for the decimal part, some other remainder. Okay. So the goal is to come up with a whole number a that is closest to, that makes the a over 60 closest to 0.572. Right? So what we do is we multiply 60 both sides. 6 times 5 is 30. 6 times 7 is 42. And actually, it should be, if you calculate this, it will be 34.32. Okay, so you can use a calculator, or you can actually just do the multiplications. This is what you're going to get, is equal to a plus 60d. So what you get is a should be 34, because that's the largest number. That's just the integer part of what you have. So here's what we have. We see that 0.572 is like 34 over 60 plus a decimal part, and that decimal part is really like 30. No, it's see, 60 times d is the decimal part of this one, so it's 0.32 divided by 60. Okay. Now, what you want to do is, for the second part, so a gives you the minutes part. So what we figured out so far is that this is equal to 10 degrees plus 34 minutes. And then there's this extra 0.32 over 60. Right? So how do we rewrite this extra part as another number over 3,600 plus another decimal part? Okay. So in other words, I need to figure out how many seconds it is, but second is 1 over 3,600 degrees. And since this is really degrees, right? This is, okay. See, this is degrees. So everything here is in degrees. Okay. So what I want to say here is, let's see. You have so let's remove the degrees. It's confusing. You want to figure out the whole number b, right? So what you do is you multiply by 3,600 both sides. So you get 0.32 times 60 equals to b plus e times 3,600. Okay. And the reason I have just 60, so if I multiply everything by 3,600, I end up with just b, because 3,600 cancels. On the left side, 60 and 3600 will cancel to leave you with 60. Okay. If you further calculate this, it's going to be 19.2 equals to b plus e times 3,600. Now there's a slight difference between how you choose A and how you choose B. See, for A, you just want to know the whole number part. But for B, what you need to do is you have to figure out the closest integer. So right now, the closest integer to 19.2 is just 19. But had this been 19.7, you would choose B as 20, because that's closer. Okay, so keep that in mind. And what you end up with is, since B is 19, final answer, let me pick a different color. So the final answer would be 10 degrees, 34 minutes, and 19 seconds. Okay. And I know that some calculators can just calculate this, change it to degree, minutes, and seconds right away. But the purpose of this question is to make sure that you know the mechanism for doing this, and that's why you need to show all your work about this. Okay. Now I still want to show you a shortcut. So what's the shortcut or more streamlined approach? Well, first you rewrite this as 10 degrees plus 0.572 degrees. And then what you do is you multiply 0.572 times 60 to get 34.32. Okay, so 6 times 2 is 12, 6 times 7 is 42, but there's a carryover, and 6 times 5 is 30. So that's what you get. And once you get that, take this 34 part, and that's your minutes. Okay, 34 minutes. Okay, and then take this other leftover, 0.32, multiply by another 60. 6 times 2 is 12. 6 times 3 is 18, so 19.2 because there's a carryover here. And then the number closest integer is 19. Okay, so you get the 19 seconds. Okay, so you really have to show this much work. I did the other calculation just to show you how things really work, but this is more streamlined approach. Find the arc length if central angle is 72 degrees and radius is 20. Alright, so for arc length, you need to know the SOR formula, S equal to theta times R. Often just read as SOR. Okay, but this is really theta. This is for the angle. And the important thing is that this formula only works if this theta is in radians. If it's not in radians, you have to convert it. So for this question, you first have to take the 72 degrees and you multiply by pi over 180 degrees. That's how you convert any degrees to radians, right? So you multiply by this, so it's 72 pi over 180. See, the degrees canceled and you don't need degrees anymore. And then since top and bottom is divisible by 9, if you divide 72 by 9, that's 8. If you divide 180 by 9, that's 20. And then top and bottom is again divisible by 4. So it's 2 pi over 5. Okay, so that 2 pi over 5 is the radian measure for the 72 degrees. And now the arc length can be computed just by doing SOR, which is 2 pi over 5 is my theta. And then radius is 20. So 20 divided by 5 is 4. 4 times 2 pi, that's 8 pi. Okay. Now, if you are provided a unit for the radius, then you should also have that. So if the radius is given as 20 feet, then you have to write down 8 pi feet. If the radius is given by 20 inches, then you have to say 8 pi inches.